I am Anil Kumar, and with the help of few videos, I am going to discuss with you rational functions. So let's begin by understanding what rational functions are. So we'll answer these three questions in this particular video. What are rational functions? Then we'll provide some examples of functions which are not rational functions. And we'll also understand how to state restrictions of rational functions. In the following videos, we'll work on wholes, horizontal asymptotes and vertical asymptotes, and then we'll try to figure out how to find equation of a rational function from given conditions. So let's begin with what are rational functions. Rational function f of x is a ratio of two polynomials. Let's say something in the numerator divided by something in the denominator, where denominator is not equal to 0, correct? And both numerator and denominator functions are polynomials. So that's very clear. So rational functions are ratios of two polynomials. The denominator cannot be 0. So that is what a rational function is. Now example of some functions which are not rational. So let me do it like this with you. I'll give you a few examples. You just tell me which ones are rational, which ones are not, right? Let us say I write a of x equals to 2x minus 1 divided by x squared. I have b of x equals to 3x squared, c of x equals to 5, and d of x equals to 1 over square root x. Now you have to tell me which one of these are rational, which ones are not rational, right? So let's figure that out. The first one here, 2x minus 1 is a polynomial, x squared is also a polynomial, so this is a rational function. 3x squared plus 1, 3x squared is a polynomial. We could treat this as divided by 1, so it is a rational function. Cx equals to 5, 5 is a polynomial of degree 0, right? Divided by 1, which is also a polynomial of degree 1, so this is also a rational function. 1 over square root x is not a rational function since square root x is not a polynomial. Is that okay? So that is how you could figure out functions which are not rational functions. Now there could be more examples of not rational. Let me write down. Not rational. Functions. So let me write down these examples in the box on the left side. For example, I could write f of x equals to sine x over x squared minus 1. Now sine x is not a rational function, right? Or I could write g of x equals to 2 to the power of x over something, right? Let's say x. This is also not rational. So these ones are not rational, correct? Since sin x is not a polynomial, nor is 2 to the power of x. So they are ratios of two functions, but not ratio of two polynomial functions. Correct? So I hope this point is well taken care of. That rational function is a ratio of two polynomials. The other polynomial could be a constant, right? Constant is a polynomial. Now let's talk about how to state restrictions of rational functions. Clearly, restrictions of rational functions are because of the denominator, right? Denominator is not equal to 0, so that leads to restrictions. So let's work on restrictions now. So I'll give you a few equations. Let's say y equals to 2x minus 1 divided by 3x plus 2. Then we have y equals to x squared over x minus 1, and then we have y equals 2. So we have different functions, right? We'll try to find restrictions on the domain of these functions. Is that okay? So we could have here x plus 1 over x plus 1 times x minus 1. So these are a few functions which I have taken. To find restrictions, what should we do? We can equate denominator to 0, right? So we say 3x plus 2 should not be equal to 0. 3x is not equal to minus 2, or x is not equals to minus 2 over 3. So that becomes the restriction, right? So we'll write here x is not equal to minus 2 over 3. Got it, right? Similarly, for the next function, we'll say x minus 1 is not equal to 0, or x is not equal to 1. So the restriction here is that x is not equal to 1. Clear? In this case, we have x plus 1 times x minus 1 is not equal to 0. So that means x plus 1 is not equal to 0, and that gives us x is not equal to minus 1. And if I write x minus 1 is not equal to 0, that gives us x is not equal to plus 1. That means x is not equal to plus minus 1. So this has two restrictions. Do you get an idea? So by equating denominator to 0, we can find restrictions of a rational functions, right? Now let me give you one example where we have no restrictions. Let's say f of x equals to 1 over x squared plus 1. Now here, denominator is always non-negative. Do you see that? It is never 0. So in this kind of rational function, we do not have any restriction. So you could have rational functions without any restriction in its domain, correct? So that is possible. I am Anil Kumar, and I hope with this video you have understood basically what is a rational function, what is not a rational function, and how to find restrictions for any given rational function. Is that okay? Now I'll move on to learn concepts about finding holes and vertical asymptotes, and thereafter about horizontal asymptotes. I'm Anil Kumar. You can always search my videos by Anil Kumar Rational Functions playlist. Feel free to post questions, subscribe to my videos, and share them with your friends. Thank you and all the best.